So for the adapter contamination, what he will do is you have to give him the sequence of the adapter. That's one of the parameters that you will see here in Galaxy. If I say perform this step, Illumina clip means remove adapter. When I say yes here, he will ask for which adapter sequence that was used. When it's your data, you will know exactly which one to choose here, because you have done it. When it's public data, it's harder to know. Yeah? So when it's public data, the safest option is to take custom here and just provide the sequence in FASTA format. When he has the sequence, he will cut the sequence into smaller pieces, overlapping pieces, yeah, like you see here. And these pieces are called seeds, and they're 16 bases long. And he will align these smaller pieces to your reads. So he will take these seeds, he will take your reads, and he will align them. And he will use an approach that is very similar to what BLAST does. Yeah, BLAST also works with seeds. Okay, so he aligns these seeds to your reads, and then he will check how good the alignment is. And that's another parameter that you have to tell him. You have to tell him how many mismatches there can be here. Yeah. For short reads, you typically use 2. If your reads are longer, you allow more mismatches. You will go for 3. We have to include or take into account the fact that we can have sequencing errors. And especially here, in this case, when we have adapter contamination, here it will pop up at the 3' end of the read, which is the end that has the most sequencing errors, the lowest quality. So we have to allow for some sequencing errors here. So he will align, he will count the number of mismatches. If it's smaller than 3, he will keep this alignment. If it's more than 2, then he will try to align this seed in the next location of your reads. And he will go over all the reads. So a lot of sequencing errors, a lot of mismatches. He will try to align that seed in a different location. If it's very few mismatches, he will keep the alignment. And then what he will try to do is he will try to extend the alignment, because this is just a seed. It's just a subpart of your adapter sequence of 16 bases. So now he's going to try to align the full adapter sequence. So he makes a full alignment, and that's what you see here. And here he's also going to calculate a score for this alignment based on how many mismatches there are. And this is another parameter. So this is the number of mismatches that you allow in the alignments of the seeds. So what I explained here. 2 for short reads, 3 for long reads. And then this parameter here is a threshold on the full alignment score. So you set a threshold. So if the full alignment score is higher than this threshold, he will keep it. And if it's lower, he will try again. So he will try to align the seed in another location. So, and in this way, by extending the alignments, you will find both the adapter dimers, because it will be a read that matches completely to the full adapter sequence, and you will find the adapter contamination in the reads, because here the 3' end of your read will map or will align to the adapter sequence. That's basically how it works. So you cut it into overlapping pieces called seeds. You align the seeds For alignments with not too many mismatches, you extend the alignments and then you put a threshold on the alignments scores.